Okay, so today we're going to have a short video on the empirical rule. And the empirical rule is a basic way to find area under the curve quickly. Now we know that since this is a normal curve, it's above the axis, so it can't be negative. And we also know that the entire area will add up to 1. So all beneath here is 100%. But you might go, well, how much percentage is between -1 and 1? Like, what is this area? And since people have been doing this for a very, very long time, we have learned that the area from one standard deviation to the other standard deviation, so if you go one below and one above, that is going to be 68% of the data. So this is 68% of the data. If you want to go from two standard deviations, so you want to go from here to here and get everything in between, you can see that that's a larger area. So that's actually 95% of the data is 2. And if we want to go to 3 standard deviations from here to here, you can see that looks like all of the data, and essentially it is, because that is 99.7%. So when we look at these things, we can see just by kind of rough estimates how much data is in each section. Between 1 and 1, it's 68. Between 2 and 2, it's 95. And between 3 and 3, it's 99.7%. And this, just by knowing these things, is going to allow us to answer a lot of questions. Let's just look at a couple questions we can answer. Okay, let's say the question is, I want to find the area between -1 and 0. Well, I know from one standard deviation below to one above, that's 68%. But this isn't the whole 68%. Like, I'm not all the way over there. So it looks like I have half the data, and I know that I have exactly half of that data because this is symmetrical. So for whatever's here, it's also here. So instead of me wanting 68, I want half of that, and half of 68 is 34. So this right here is 34% of the people. Let's look at another one. On this one, I want to go from -2 to 1, so I'm stopping early, so it's not going to be the entire 95. Now I like to break this up into two categories because I think it's a little bit easier. I'm going to break it right down at the center because I know that this is going to be half of the 95 data. So that's going to be half of the 95 data, which half of 95 is 47.5. And then we just have this little section in red that we have to find. Well, we just found that in the last time because that's half of the 68. So that would be 34. And then when we add those two things together, we're going to end up getting that this is 81.5. So sometimes we have to piece a lot of these things together, but you can see that you can pretty accurately predict a lot of these areas. Let's do one more. Let's say I want to find this area. So I want to find 1 and above. Well, we don't have really any of the rules that tell us how much it is above, but I know that from here to the end, that's 50%. And we actually know what this portion is here, because that's from 1 in, and that's half of the 68, so that's 34. Well, if this entire thing's 50%, and the only part I'm missing is the 34, how do you erase something in math? Because we want to just erase that portion, that 34% right there. Well, how you erase something in math is you use subtraction. So we would have 50 minus 34, which would end up giving us I think 16%. Or 26%. No, 16%. Double checking my math. Yeah, sweet. I did it right. So we can find all of the percentages in this table for the standard deviation just using 68, 95, and 99.7. Try the different problems today. If you get stuck, let me know. These obviously don't always have to be 0, 1, 2, and 3. They can be different numbers. It might not start at 0. But again, if you want to, you can convert every single of these charts back to here using z-scores. So again, if you get stuck with anything, just let me know.